be learning about a closed system. To put it simply, a closed system is a system that energy cannot enter and energy cannot leave. So however much energy you start with, you will also have to finish with that much energy. Now, there are multiple ways that we can represent a closed system, but the easiest is going to be a pie chart. We can use that pie chart to show both the type and the amount of energy present before, during, and at the end of an energy transformation. Now, a few hints to make sure that your system is going to be as easy as possible will be to make it as big as you can. That way no energy is allowed to leave and no energy is allowed to enter. Again, that means if you start with 100% of your energy, you will have to end with 100% of your energy, but it can be in a different form of energy. Now, the first step in any problem would be to define your system, and you have to remember to make it as big as possible. So for this case, we're going to take the ball and the earth as our system. Now, at the very top of the ball drop, you want to know how much energy is present. Well, since we made our system as big as possible by including the earth, that means we have 100% of the energy present at the top, at the middle, and at the bottom of the drop, because it's a closed system and energy cannot leave. If you remember back to the analogy of the Stewie system, Stewie is not allowed to throw any blocks out of his window here, and Brian is also not allowed to bring any blocks in. So if there's 100 blocks in Stewie's room to start with, there's going to be 100 blocks in Stewie's room to end with. Now, keeping the same system of the ball and the earth, we want to know how much potential gravitational energy is at the bottom of the drop. Well, at the very bottom, the ball has no height, which means it can't have any potential gravitational energy. So there is 0%. And if you notice the word joules behind it, that's just a unit of energy. We'll talk more about it later, although you may have heard it in some other classes already. So we all know that at the very top of the drop, before the ball is moving, it has 100% gravitational potential energy. But at the very bottom of the drop, it has 0% gravitational potential energy. So what happens to that energy? Well, we're in a closed system, which means the energy can't leave and it can't enter. So the only option of what it could have done is changed into another type of energy. And since at the very bottom of the drop, the ball is moving really fast, it actually gets turned into kinetic mechanical energy. Alright, now there are a few different ways that we can show this in a pie chart, and I will go ahead and show you two of those ways. So for pie chart A, when the ball is being held at the very top of the drop, it has 100% potential energy. You can either denote that by saying there's 100% gravitational potential energy, or if you want to, you can go ahead and color in the circle all the way to show that's 100%, and then right next to it, you would write potential gravitational energy. Now, pie chart B is a little bit more difficult than pie chart A because now the ball is being dropped. So since it's not as high up, it doesn't have 100% potential gravitational energy. but it is above the halfway mark, so it does have over 50%. Let's go ahead and fill in the first bubble to start with. We remember from the last slide that it's 100% potential gravitational energy. And pie chart B is going to be slightly less than 100%, but over 50% potential gravitational energy. And since it's now moving downwards, that means part of the potential gravitational energy got turned into kinetic mechanical energy. So for pie chart B, we have roughly 2/3 potential gravitational energy and 1/3 kinetic mechanical energy. Alright, now let's do the whole thing. So we will start back up at pie chart A, and we know that that's 100% potential gravitational energy. Then pie chart B is roughly 2/3 potential gravitational energy. And roughly 1/3 kinetic mechanical energy. And then if you remember from back at the beginning, in pie chart C, the ball is just about to hit the ground. So we have absolutely no gravitational potential energy and 100% kinetic mechanical energy. So just like in the Stewie example, Stewie wasn't allowed to throw any blocks out of the window because it was closed. Brian wasn't allowed to come in and give any blocks to Stewie because it was closed. So all 100 of the blocks that began in Stewie's room also ended in Stewie's room. But he could have put them under the rug, he could have put them in the tub, he could have put them under his bed, he could have done anything he wanted. Just like in this closed system, we started with 100% energy and finished with 100% energy, but there was an energy transformation that went from potential gravitational energy to kinetic mechanical energy. All right, and this example is something for you to think about. Instead of the ball being dropped and then speeding up, we are starting off at throwing it from ground level all the way into the air. So at ground level, there's again no potential energy, but since we are throwing it upwards, we do have kinetic mechanical energy. And it is going to be the entire bubble, all 100%. Then at the very top, the ball is not moving at all, which means that we have 100% potential gravitational energy. And for the middle pie chart, it's not quite halfway, which means we don't have quite 50% gravitational potential energy. Instead, we probably have about 1/3 potential gravitational energy, and maybe 2/3 kinetic mechanical energy. So, the big things to note about closed systems are that energy cannot enter and energy cannot leave, but it can transform. So if you start with 100 blocks of energy, you will also finish with 100 blocks of energy. But that energy can change from potential gravitational to kinetic mechanical. It could change from kinetic mechanical to kinetic sound. It could change from kinetic electromagnetic to kinetic light. It doesn't matter what types of energy are there, as long as they always add up to 100%.